Okay. Good. Well, we are being to talk about Qube2Space. It's a competition for high schoolers that need to make prototypes, PocketQube prototypes. But first, we are going to talk about 𝗖cie because, yeah, we are here and we made the competition. So, let's start about our team. We are actually a rocketry team, the single one and, well, the first one and the single one from Romania. We are based on University of Politehnica, Bucharest. We start with 8 people in 2021, and now we are 30 people, in 20 members in our team. Here there are 2 photos. One is from the first edition of Qube2Space, and the second one is from this year, actually in November, in the start of November. Okay, our first project was Project 𝗖𝘀. We started in 2021, in March 2021. We started doing a rocket, a supersonic rocket sounding rocket. Actually, the first try of that rocket was in 24th of February in 2022. Does everyone know what's happened in 24th of February? Do you heard about this date? Well, actually, this date is when Russia invaded Ukraine. And Romania has a border with Ukraine. And yes, well, it's something with the presentation. The quality is low. Probably. Well, in 24th of February, we go in a military base with our sounding rockets of 30 kilograms that need to fly to 10 kilometers. So, you know, a sounding rocket near at the border with Ukraine, in the day when Russia started to invade Ukraine. It was a very unlucky day. And we go there, we stay 6 hours on the launch pad with the rockets, and of course, we didn't have a proof to launch the rocket because it was a war. It was a war near our border. So we need to go home. We take some photos, we assemble the rocket, we stay, we stay with the rocket on the launch pad, and that's all. Well, we have some problems with the presentation. Okay, but we never give up. So that was in February, but in July, all the world moved to the east part. So the border with Ukraine was more safe with us. So we go again in the same military base, and we go to launch. We managed to launch. Can you show that? Okay, actually here's a video with our rocket. I hope it can be played with my colleague. Well, actually this rocket was the first supersonic rocket entirely developed in Romania by a student's team. All the parts of the rockets were made by us, developed by us, and tested by us, except the propellant. We are not chemistry engineer. We are not making the propellant, and we don't have signal for the moment. But we don't have capability to manufacture a propellant for a rocket. So we made everything from the fuselage to airframe to payload to flight simulation, but not the propellant. And here's the video with the launch. It achieved 8 kilometers, 8,181 meters, with the maximum velocity at 1.7 Mach. You see the launch? And of course, was a successful launch. It was the first one, and it was the highest altitude in the southeast of Europe that a rocket could fly, a rocket made entirely by a student team flight. So yes, it was a successful one. After that, yeah, I think it's working. You put it down. Trebuie să-i cu USB-ul să-l pui. Okay. So, after we managed to do that, we see that in our faculty, in our university is the single one faculty of aerospace engineering. And we see that year by year, the students are going down. The number of students are decreasing. So we start a competition for high schoolers because today high schoolers are tomorrow students. So we start to make a competition. It's called Qube2Space because our team is called 𝗖𝗀. So it's about pocket cubes. That has 3 phases. In the first phase, after the registration, every team needs to be registered. So after the registration, they make a preliminary technical report. They need to write what they want to do. We give them a feedback. They have a budget, a maximum budget. In dollars, it's something like $160 budget that we offer for their prototype. They have technical requirements. If everything is okay after the first feedback, they make a final technical report. And after the final technical report, if everything is good, if their mission, they need to have 2 missions, one primary mission and one secondary mission. The primary mission is given by us, and the secondary mission, it's something that they need to choose. More of them make, I don't know, they have some experiments about radiation, one of them about air quality, for example. This year, the primary mission was temperature and acceleration on 3 axes. And the secondary was chosen by them. And everything is okay in the final report. They're coming to our university. They are staying 4 days in our university. And they are making the physical part, the hardware part of the satellites.
Okay, so yeah, once they arrive, we had to give them like safety instruction because there are like really powerful equipment. So how to use like a current source, the lead cone, the soldering equipment, and something like that. Some of them never soldered before, but they have designed their own PCBs at home. And we gave them a little technical feedback on how to work their projects out, and other stuff like how to protect their analogic lines. Okay, so in the second day they moved on the exhibition hallway. So yeah, other people came with their kids and looked at their projects and asked them questions. We also helped them. We had some very talented teams. So we had a team from the Republic of Moldova that like managed to solder freehand surface-mounted devices with only 0.5 millimeter of clearance between the pads. So that's quite impressive for high school students. Okay, and after they built the projects, we like gave them the prizes. We had 3 PocketQubes that were selected to launch with a rocket the next time we launch it. So we had like the best technical projects, the most scientific value, and the best overall. We had one winner from the Republic of Moldova, one from Estonia, and one from Romania. Okay, so yeah, this is the debrief. This is the PocketQube from Space B, the one from the Republic of Moldova. So it was very, very well worked and tight. It has a lot of functionality.
Okay, about statistics. This was also the second. This year was the second edition. It became international because before Romania, they have 2 more other countries, Estonia and Republic of Moldova. There were over 100 high schoolers involved in that competition, 15 accepted teams, because how I say to you, after the final phase, the first phase, we accepted just a part. Half of the teams that are applied are accepted because we are offering them all the budget, all the components are buying by us, all the equipments are buying by us, and we are offering them the launch of the prototypes. So we have just 50% of acceptance in that competition. Yeah, you can. That's the rocket from this year. Also is the rocket that managed to launch the winners of this competition. That's from Spaceport America, the competition we go this year. And here you see the launch is the most powerful rocket made by us. It's almost 2.05 Mach maximum velocity, double of the velocity of the sound. Yeah, that was here the camera didn't catch the rocket. So it was made in July 2023 this year. It's the biggest rocket, and it has a diameter of 120 millimeters, so enough to put the 3 PocketQubes inside. If you are going to see the next slide, yeah, that's a slide from the Spaceport America. It's one of the biggest achievements when you go with the rocket. Next. Yeah, why are we making Qube2Space? How I say at the start, because we have an opportunity to grow as a student and especially for high schoolers. In Romania, the students in aerospace field the number of students in aerospace field decreased in the last years, so we need to manage that to recover the numbers. We can learn from each other, they can learn from us, we can learn from them because their initiative missions have a lot of good ideas that can apply in actually good projects and in a real project, in real space projects. And of course, we can prepare the next students to be more passionate about aerospace field and be more good engineers, probably. You can see our sponsors, our primary sponsors. Next. And about next projects, well, there says Project Nor. In the left, what's a rocket, but it doesn't appear because it's got the display. So the next project, it's Project Nor. It's bigger than Luna, probably with higher velocity and bigger. What's new on this rocket? All the rockets have a maximum payload up to 5 kilograms. So we can put in the same rocket from 1 kilograms to 5 kilograms without changing the stability. Well, you are changing the stability, but your safety range is in the same place because our rockets are modular. If I put 1 kilogram, I'm the safety margin for the stability. If I put 5 kilograms, I'm the safety margin of stability. But for example, if I want to put 7 kilograms, being modular, we can change the empennages, the fins of the rocket, so we can manage the stability. All the parts of our rockets are changeable, so we can manage the stability very easy. The Project Nor will have a vacuum chamber in our rocket that can manage the pressure. We can make vacuum in the rocket, and our rocket having a maximum acceleration of 30 G. You can test a prototype of a PocketQube, you can test a sensor, you can test something on a vacuum in the maximum velocity of 30 Gs in a real rocket that fly actually to 10 kilometers. After that, Qube2Space 2024, we are managing to raise the budget. I just say to you that you have $160, the budget per prototype. We are managing to grow up to $300 per prototype. We want to have minimum 5 different countries, participants, and we are managing to search after the international sponsors for the competition. And from January, we are starting to work on a PocketQube prototype because we are doing rockets, we are doing very good in what we are having now. And yeah, we are trying to get our first PocketQube satellite. Okay, these are our contacts, our social media, and thank you.